Good evening, good evening. Nice to see you all. So, as I have put in the chat, do say hi. It is a great chance to ask and answer questions. Yeah, I will ask you questions as we go through to check what's going on and see if there's any bits we've misunderstood. So it is helpful if you can drop stuff in the chat. At the moment, you would need to subscribe. You can just unsubscribe at the end of the lesson if you like. Don't worry about that. From next week, when we do the main course stuff, you won't actually need to subscribe. There's going to be a slightly different way we're going to do things, but for tonight, you would need to. So, catching up, Riley, hello, hello. Sanjit, hello. Moonlight, hello. Path, hello. Back tomorrow. I mean, look at you. That's the dream, right? So if you can just chill out and have a few extra days. And the freeze, oh, the freeze. I remember those days. You go from year 11 where it's just like intense all the time and you do so many subjects. And then suddenly you get free periods and you don't know what to do with yourself. Uh, do a bit of work. Do a bit of work. It's useful, right? I promise. I promise. If you do a bit of work in your freeze, everything's just a little bit easier. So that's good. Aisha, hi. Yashi. Nice to see you, Yashi. Good stuff. You're just kind of attending all of the ones because you were in the year 11 one as well, right? The higher one. That was good. And now we're just going to learn a bit of A-level maths too. Why not? Might as well. All rightio. So we are going to remember it from the physics live stream. There you go. You see, mango. Nice. Good evening. So we are going to learn some maths. That's the point, right? So we've picked something that is new or should be new for most of you. Savio, good evening. So it depends. Some of you, if you've done, it's not very popular these days. If you've done the additional maths, you might have done a bit of logs, but for most of us, logs is a new thing. So it's nice, right? But conceptually, it's something that people do find a bit weird. So I'm hoping I can show you that we can understand it, right? Even you take something a bit odd, you can still kind of get your head around it if you get a good explanation of it. All right. So if you've got the workbook, that will help. But if not, just a pen and paper's fine, right? For maths, you don't have to have it all written out for you. You can just quickly jot a few notes down. So something to write with is going to be really helpful. First time doing A-level maths, what should I do to get ahead? So we're a good place to start, okay? So it's just trying to do, you don't have to kind of try and complete A-level maths in a year or anything like that, or kind of read 6 months ahead. You just need to make sure you stay on top of the stuff you are doing, right? So whatever you're doing at school, whatever you're doing with us, if that's kind of where you choose to go, just make sure you stay on top of it. Lots of practice. There is no magic shortcut. I promise. If I had a magic shortcut for you that was going to make A-level super easy, I would tell you, right? But we're going to explain things really clearly, so then it's all going to make sense. Okay. So just very quickly, if you do know anyone who is also starting A-level maths, drop them the link, right? So it's free, so they can obviously come back and watch it later. That's kind of one of the things, right? So it's all recorded. You can just drop in later and watch it back. So even if they're not available now, they can have a watch, follow along, and then it's good for them to kind of see what we're doing here. And we'd like to build ourselves a little community, right? Because we're all on the same page trying to learn maths. So it's nice when we get that sort of environment. Okay. So I'm going to do a brief intro for myself, just so you've got an idea of who I am. Okay. So my name is Guy. So I'm not just some random guy that does maths. My name is actually Guy. So that's the deal with that. I've been teaching for 12 years. In all that time, it's mostly been A-level is kind of what I've done a lot of. It is me. So I'm doing the year 12 maths this year, maths and further maths. They're separate courses, but if you're doing maths or you're doing further maths, whatever you're doing in year 12, it's me that's doing it. So there you go. So you get to see what it's like tonight. I've got a first class degree in economics. So some of you might be thinking, why on earth are you teaching maths if you're doing an economics degree? So some of you might be doing A-level economics and have signed up for it so far. If you eventually want to go down the route of doing economics university, it is very mathematical, okay? A lot of maths in degree level economics, lots of pure maths, differential equations, matrices, lots of statistics, econometrics, all this kind of stuff. So if you've got that in your mind and you think, yeah, I want to do maths, I want to do economics, make sure you do the maths, okay? How did I revise for maths? Just loads of practice questions, right? Again, that's it, right? There's no magic shortcut. If I do loads of practice questions, when I get into an exam, I can look at the question and say, I've seen one like this before, so I know what to do, okay? I have also been marking A-level maths exams for about 10 years now. So I get to see all the kind of weird stuff that some students do when they misunderstand questions, and I get to kind of pass that on to you, right? So you're not going to make those same mistakes. So again, that's the idea, right? It's then helpful for you to get that insight. Okay? All right. All right, sure, yeah. Obviously, if anything with names and stuff, obviously do correct me. I'll do my best. So, do you need further maths? You don't have to do further maths. It does help. So, I did further maths as one of my A levels, and when I went to my economics degree, the first year when everyone was doing all the maths attached to the economic side of things and all the courses we had to do for my entire first year, I'd done all of it already. So my first year of maths at uni, alongside my economics, was a breeze because I'd done all of it. I was teaching all my friends how to do it. So there you go. Okay, biochemistry, maths. That's quite the set. I did maths, further maths, physics, and economics. So it's intense. Right, we are here to do some maths, so we're going to get started. All right. So you've probably seen the lesson title. You might have never heard of it. You might have kind of been thinking, what's that? So a logarithm is the inverse of doing an exponential. So as we're kind of explaining here, the idea is that all functions should have an inverse. So if I square something, right, x squared, I can root it, and that is doing the inverse function, right? So when you've solved equations, you say x squared equals something, you can square root it, and then that gets you back to just x equals, okay? Well, if I raise something to a power, right, so if I say something to a power, the logarithm is the inverse of that, right? So that's what we're going to try and crack today and get ourselves started on how logs work, right? So we've got an example here. So if I said y equals 3 to the power of x, then I have this inverse version here of y equals log base 3x. So we're going to talk about this a little bit, and here's an example with some numbers that tries to make it a little bit more concrete, because once you see it with numbers, it starts to make a bit more sense, right? If you start with it with x's and stuff, it all gets a bit confusing. So here we have what I'm going to call or refer to as a power statement, right? So this is a power statement. You're used to these, right? These are not new. You're used to 3 squared equals 9, 5 cubed equals 125, right? All these things. That's not new, okay? Every power statement has an equivalent matching log statement, right? So I'm not going to say logarithm all the time. I'm going to shorten it to logs. So I have a log statement for any power statement. So really, our job is to learn how to convert between those two correctly. So if I start with a power statement, how do I turn it into a log statement? Or if I'm doing it the other way and I start with a log statement, how do I turn it into the power statement equivalent? That's our aim, right? If you can do that, then you've got logs and you're all sorted and you're ready to go. Okay? So the question it's answering, right? So if you look at this with the numbers, I know we've got this general one here about A's and B's, but if you see it with numbers, it's a bit easier to understand. So this statement here is saying, what power do I need to put on 3 that I've written here, this base, right? So this 3 down here, that's the base. Move that out of the way, sorry. Let's do it in a different color so we know what we're talking about. So this base 3 here, that is the base. It's saying what power needs to go on 3 to get the answer 9, right? So that's the answer. And then what's the power? Okay? So we all know that if I do 3 and I put it to a power of 2, what I'll get to is 9. Okay? Jay, yes, you can come back to this. You can come back to the live, or it'll all be recorded and freely available, so you can review it later if you want to, if you need to dip out for any reason. Okay? So you're used to writing 3 squared equals 9. So now we have this log equivalent where I say log base 3 of 9 equals 2. So before we move on, I'm going to do another example, right? I'm going to see if we've got the idea. So if I said, I'm going to write a power statement first. So if I write a power statement, so let's take one that we're all familiar with. So if I say 2 cubed equals 8, okay? So I want to turn that into an equivalent log statement, okay? So let's think about where the different things need to go. So when you do your powers here, this 2, you might never have used the word, but initially when you were taught it, your teacher at school might have used the word. They might have called this the base. Well, there's a reason it's called the base, because it's the same base we're writing in our log statement up here, right? So I'd have a log base 2, okay? So I'd say log base 2. There we go. Look, some people are starting to have a go. Nice boys in there. Yeah, Yashi. So I've got log base 2, and then the answer, right, this 8 here, that's what goes next. And then the question is, what power do I need to put on 2 to get 8? And we know that's 3, right? We'd written the power statement. We already knew the answer to that one. So I'm saying log base 2 of 8 equals 3. All right, you've got it. Yeah. So I know some of these things are a bit difficult to type in the chat, but I'm going to know what you mean. So if you're writing the stuff like Yashi's written, like Moonlight's written, absolutely fine, right? Pretty simple, right? Path. That's the idea. Okay. If I go the other way and I said I've got a log statement, right? So I'm going to do one more L. I'm going to go the other way. I'm going to start with a log statement and turn it into the power statement. Okay. So if I said log base 5 of 25 equals 2. Okay? Because what that's saying is, what power do I need to put on this base here? That's my base. What power do I need to put on 5 to get 25? What power do I need to put on 5 to get 25? Well, again, we all know the answer to that is 2. So if I can rewrite that, let's do it in blue. If I rewrite that as my power statement, I'd say 5, that's the base, to the power of 2 equals 25. So we've rewritten, right? We've done one each way. So we've done one where we started with a base power statement, we've turned it into a log. We've started one where we started with a log, we turned it into a power. So now that's all we need, right? If you can do that, you're already off to a flying start with logs. So that's what we're going to have a look at now. I'm going to try and do these. So all of these questions that you might see if you've got your workbook in front of you, otherwise they'll pop up in a second. The aim is to do all of these without a calculator. We will not need a calculator for these because they're all numbers that you might be familiar with. Some of it's a little bit of the power stuff from GCSE. So if you remember things like if I'm rooting something, that's a power of, oh, I've forgotten. Can you remind me? If I square root something, what power goes on something that I'm square rooting? Do we remember what that might be? Because we might not have thought about that for a little while. So if I'm square rooting and I want to do root x or something, what power do I put on it? There we go. Nice stuff, Mango. Watch out, Yashi. You've got, oh, there we go. We've rethought about it. Awesome. Yeah, nice one, Moonlight. Savio, good stuff. Path, yeah. Fun car. I'm just going to go fun car. So I'm going to say it's a half, right? You know that. So it's going to use some of those bits of knowledge from GCSE, but we don't need a calculator to answer these. Okay? So L. So far, we haven't got to the sort of thing you might see as an actual question. We're building up to kind of get to that point. And you'll see some things that you might see on a paper. We can talk about it then later on. Okay? So we're going to try and write the answers. Okay? So we want to do the answers. We're missing answers, right? So here, I've got log base 3 of 81. So we need to translate that in our head to what the question it's trying to answer is, so that then we can write down the answer. Okay? So we can think of that as a power statement if it helps, right? But if you've already got a good idea of what's going on, you might not need to do that. You might say, oh, I know what the answer is. Great. Okay? And some people are starting to get their head around it. But if I said, now, 3 to the power of I don't know equals 81. That's the question we're trying to do, right? And we don't need a calculator for that because as we've all spotted, right, and we all know in the chat, that's just 4. There we go. Look, we're already doing logs. Yeah, you're all way ahead of me. We're already doing logs. Now, key bit to note, it was on the previous page, but I didn't point it out there, but I'll point it out now. If you see a log and it doesn't specify the base, it's kind of standard notation. It means the base is 10. Okay? It's just a thing. You'll see it. You might have a calculator with a log button on it, and it just says log and nothing else. What that means is the base is assumed to be 10. So that's just kind of standard mathematical notation. So again, we might think, right, okay, log base 10, and then I'm trying to work through and right, I've got a million, right, okay. So then I think, okay, what question is that trying to answer? And I work my way through and I can think about the power statement if I need to. So I'm going to write it again this time, but as I go through, I'm going to start dropping the power statement and we're just going to kind of do our log bit. So 10 to the power of something equals a million. And you all got it, right? You're all way ahead of me, right? So we've all got the idea. So Yashi was in there, Moonlight, awesome. Yashi wrote out with the power statement kind of attached. Aesthetic Taurus, that's a new one. Riley's got it, fantastic. Path, Aisha, awesome, right? It's just 6, because 10 to the power of 6 equals a million. Awesome. So now, we're into some of our rules of indices from GCSE. So this is where we might have to remind ourselves of some of these. So log base 5 of 1. Log base 5 of 1. So again, think of the power statement. And then it's one of our rules of indices that you might remember as like a standard result. There we go. Look, this is awesome. So anything to the power of 0 is 1. We've got an explanation from Path. Nice. So what that means is actually, so you're all right. Yeah, absolutely. It's 0. So actually here we've said it's base 5, but I could generally say, right, I could extract that as a bit of information, say log base anything of 1 is 0. That's now a general thing we could say, right? So if I see something later on and it's log base something of 1, it's just 0. Okay, so it didn't have to be a 5, it could have been anything, but it's a 5 is what we used. Okay, let's see if we can start kind of working our way through a little bit quicker now. So log base 7 of a 7th. Log base 7 of a 7th. So again, that's rules of indices. How do I get a 7th? By putting a power on. You kind of think back, because it might have been a while since we thought about some of this stuff. You know, GCSE was 3 months ago. Didn't think about it for a while after that. You know, it's not the sort of thing we might have done over the summer. Oh, we've got the nice word, reciprocate. We'll take the reciprocal. So I don't necessarily, so when you say negative reciprocal, we have to be careful. That's a phrase we typically use when we're talking about the gradients and perpendicular gradients. Here we just say it is the reciprocal, because when you say negative reciprocal, it means we put a minus in front of it, which isn't the same as putting it in a power, right? So that's just a slightly different thing, all right? But we've got the idea. So it's going to be -1 because 7 to the power of -1 is 1 over 7, right? That's, again, one of your rules about negative powers, okay? And then we reminded ourselves a little bit about this one. So this is a nice simple one that we can all quickly smash out. So log base 11 of root 11. Root 11. We talked about that and what that means. So Yashi's in there, yeah. Savio's in there, Moonlight Path, nice. So we can see, we already said if I square root something, the power is 1/2. So there we go. Nice one, Sanjid. You're in there as well. Fantastic. Okay. So these last few are now, I'm not going to say they're difficult. You know, you guys are going to be awesome at maths, right? You picked A level, so we're not going to say they're difficult, but we can have a little think, because maybe we're going to combine some of them or think of some slightly more unusual examples. So log base 2 of an 8th. Okay, log base 2 of 1/8. How would I put, remember the power statement? How do I put a power on 2 and get the answer of 1 over 8? Right, so it's like combining your rules. But you're already way ahead of me, right? So I know you've got this. So Jay was in there, yeah, nice one. Yashi, good. Path, Savio, Riley. Taurus, I'm just going to go with Taurus. I'll shorten a bit. It's -3, isn't it? Because 2 to the power of -3 means I do 1 over 2 cubed. Nice one, L. And then I can work out 2 cubed as 1 over 8. So I've got -3. Fantastic. Okay. Log base 125 of 5. So what power? Remember the question. We've got to make sure we get it the right way around, Savio. So just be careful. 125 is the base. So what power do I put on 125 to get 5? Right? So again, if you spotted 5 cubed equals 125, you can then kind of reverse it back in your head. So we know then it must be 1/3, because we're going to cube root 125 to get 5. Awesome stuff, right? We're flying through this. We're going to absolutely smash the rest of this today. Log base 3 of 1 over. I mean, we're stretching it a little bit now. So 1 over root 27. Right. So now we get, it's a little bit trickier. Okay. So you might need to kind of, maybe we do need to write our power statement now. We might feel like, oh, I'm not sure. So maybe I'll just jot it down if you need to. So 3 to the power of something equals 1 over root 27. Okay. There we go. Look at this. Bunch of bright sparks tonight. Awesome stuff. Great job, all of you. Yeah, fantastic. So we know we've got 1 over, so it's a minus, right? Remember, it's like you just build it like you did GCSE-wise and stuff. So 1 over, then I've got a square root, so it's got a denominator of 2. And then to get 27, we know it would be 3 cubed. So we just piece it together, right? -3 over 2. It's the same thing we would normally do. And now the last one, I don't like the word trick question. I never use the word trick question. There's no such thing as a trick question. There's questions that test your understanding. That's what there is. So we don't like trick questions. We do questions that test our understanding. So this one's one for thinking about. Log base 9 of -1. So be careful about what that means. Remember, because it's very easy to start thinking, ooh, I'm doing 9 to the power of -1. Remember, that's not what it is, right? So you can think of your power statement. So if I'm saying 9 to the power of something, remember, we don't know the something, equals -1. So there's a question there, isn't there? Is there a power I can put on 9 that's going to magically produce -1 out of somewhere? Don't think there is. So complex numbers. This is not complex number. Remember, that's so Shane. I don't know how much you've seen about I and stuff. Obviously, that's in further maths only. That's when you root negative numbers. That's not the same thing. Okay. So this, as a few of you have said, we would say is undefined, right? So I know your calculator would say math error. If you tried to type log of -3 in or something, it'll say math error. But you know, that's what your calculator says. Someone picked that at Casio to say, "Ooh, we're going to put math error whenever something goes wrong." Undefined, right? You can't take the log of a negative number. That's a general rule. So again, like we had this general thing over here, we can say cannot take log of a negative number, right? It's like a little thing, a rule you can remember, and they test that sometimes in questions of a negative number. Awesome stuff. Right, we're smashing this. Okay. So we're going to have a look at the next bit. You don't need to apologize, Shay. If you've heard of I and stuff, right? And as I said, that's further maths. You know, and if you don't know what it is, then you might think this is the chance to use it, right? It's absolutely fine. Okay. As I said, I teach the further maths bit as well, and we do complex numbers in that. So we do the bit where it's relevant, where we do square root of -1 and all that sort of stuff. But if you're just doing single maths, you don't need to worry about any of that stuff. That's not in kind of normal A level. That's only in further maths. All right, time to move on, right? Because we want to learn more logs because we're absolutely smashing this out of the park. So you're doing further maths as well, but we've got no problem, right? So just for your information, I know we're not doing a trial one for further maths, but there is a further maths course which you would only need to do that one. You wouldn't need to do this and the further maths. So you just do just the further maths course, and we cover all the single math stuff in that as well. Okay, so just so you know. Okay, so now we're kind of shifting the bit where we don't know. We're sticking an x in, so it's almost like an equation now. But this, it's no different, and this is the big thing I really want to try and hammer home, is that if you've understood what we've done so far, this isn't any harder. This isn't any more difficult than what we've done in the first 20 minutes or so. It's no different. It's exactly the same thing. It just looks slightly different because we've stuck an x in it. But you remember from all the stuff you did at GCSE, just because you put an x in something doesn't make it difficult. So if we can look at log base 3 of x equals -2 and say, well, I know what that means or what that's asking me. This time, our power statement, which I know loads of you are way ahead of me, but just in case anyone's not sure, x equals 3 to the power of -2, right? That's the equivalent power statement, right? So I take my log statement, I put 3, the base, to the power of -2, and that's the answer that then is where my x is. So then we just work that out. Again, I don't need a calculator for that, as those of us have done. X equals a 9th. No more difficult, right? It's just as straightforward, okay? Awesome stuff, right? I'll tell you, we're absolutely smashing this. I'm just telling you, logs is one of the things that a lot of people find really, really tricky, right? So if you're looking at this saying, oh my gosh, this is really straightforward, you're off to a great start, right? It's like week 1 of A-level maths and we're smashing logs. Right, so that was our first one. So then B, same thing. So again, if I can rewrite it, log base 9 of x equals 3/2 and say, okay, what does that mean? I can write that. Again, those of you are way ahead of me. So I say x equals, and I take my base, which is 9, and I put the power of 3/2 on it, right? So x equals 9 to the power of 3/2. And then I can work that out because I can square root it and then cube it to get 27. Awesome stuff. We've switched language. We're kind of that confident with logs. He actually is doing it in German now. Okay. So again, C, we've just switched where the unknown bit is. But if you've been following along and you understand all the stuff we've done so far, again, loads of you are way ahead of me. Taurus, Moonlight, Shane, Elle, we're all miles ahead of me. Parth, Yashi, right? Maybe I don't need to be here, right? We're all just so good at logs. So if I rewrite it again, in case anyone's looking at it and thinking, I'm not sure why everyone's typing 4, where does that come from? I take my base, x here, and I put the power of 2 on it, and then that equals the answer of 16. Okay? And x squared equals 16. Now, we will just briefly mention, because obviously you're used to, again, GCSE going, oh, right, okay, x equals 4, and you're obviously used to maybe putting plus or minus in, right? You might be kind of used to doing that as a habit. Now here, because we're dealing with logs, we wouldn't take the negative value, right? We would only deal with the positive because of those issues around powers and negatives and all the sort of stuff it might cause in terms of problems and stuff. Okay, so you didn't put it on, right? So again, no one put plus or minus 4, just in case anyone was wondering. We'd just take the positive value, just 4 only. Okay? Oh, wow. I mean, what are we in now? Is that one, is that Spanish? We're going beyond my language realms, right? German, French, I can just about do. Maybe a tiny bit of Italian. That's about my limit. I never did Spanish when I was at school. And then last one, exactly the same thing. So if I say x to the power of a half, right? So I take my base and I put my power on it, equals 1 over root 3, right? So again, same thing. We're at that point. So x to the power of a half, we want to get back to x. So you might remember then if that means root x, I would square both sides. So that would give me x equals a third. There we go. Another set of difficult log questions. I'm not saying they're difficult. We've got the idea, right? Awesome stuff. Okay. Oh, wow, we really are. Right, okay. You've gone way past my language knowledge now. Might have to stick with it. It might get a bit more challenging. We might need to stick with English in a minute. But there we go. All right. I'm going to pause. Has anyone got any questions, right? Some people might be looking at this thing and do you know what? I've completely lost the plot. I don't know what's going on here, right? Because I know lots of people obviously have got the idea, but is anyone unsure or got any questions about where any of that's come from or what we've done so far? Okay. As I said, don't be shy, right? This is the chance. It's a relatively small group, right? So there's not loads of you. So I'm more than happy. Can you explain which bit? I need you to be a little bit more specific, okay? So just can you explain? Is there a particular example that we haven't quite got? Just if you can be a bit more specific, it helps me to then kind of focus in on the bit that you're not sure about rather than just kind of generally explaining all of it, right? Because there might be bits that we're a little bit unsure of, right? I know it might take you a little minute to start. The log part for the A and C. Okay, so remember, if I write that, so log base 3 of x equals minus 2. I'll do D as well after. So remember, this is asking you a question, right? So you can almost ignore the minus 2, but it's saying, what power do I put on 3 to get x? Now, because x is obviously an unknown, we need to know the answer to that. So we have minus 2 is the power. So we take this. Remember, it's useful to remember this is called the base because that's the thing you put the power on. Okay? Really, really, that language is not accidental choice of words. It's called the base because the base is the thing that has the power when you do kind of indices and that sort of stuff. So if I say 3 is the base, I put the power of minus 2. That's this, right? This is your power. And then x is the answer effectively. So you say x then goes there. So what power do I put on 3 to get x? Well, minus 2 is the power. So x is 3 to the power of minus 2. And then 3 to the minus 2 is the 9th. That's GCSE stuff, right? So 1 over 3 squared. Okay. D is exactly the same, right? So we've done exactly the same thing, no different. We're saying x to the power of a half equals 1 over root 3. The difference then when I work that out, I might remember that root x is x to the half. So then I would square both sides to get back, right? So if I square 1 over root 3, I just get a third. Okay. Not sure yet, actually, Al. I'm not. I haven't been given kind of latest numbers, but hopefully a few, right? And it's going to be awesome, right? Build ourselves a little community. Share. Hopefully that's helped. As I said, you will sit. There's going to be more things where you get to practice all of this. So even if you haven't got it all 100% right now, and you're maybe like about 50%, honestly stick with it, and bits start to click as you go through, right? And remember, you can always go back and watch all of this, some of this at any point in the future. Okay. We'll get to that at the end, Shane. Don't worry. Okay. So now you will need a calculator. So look, I'm going to get my calculator. Look, there it is. Ta-da! So if you haven't got a calculator with you, that's absolutely fine because you can write the thing you would type into your calculator, and that's good enough because then obviously you just type it in. If you've got a calculator and you're not sure where the particular button we're going to use is, same thing, just write down what you would type in and it will take a bit of fiddling around to kind of find where it is. When we start the main course, I'm thinking we're going to do like a poll on who's got which calculators, and I'll try and make sure we're using the most common one, or we'll switch between a few, and everyone gets to see a bit of how to use their calculator and stuff. Because now we're starting with power statements where we wouldn't know the answer. I don't know what power needs to go on 3 to make 17, right? I can't tell you that. I can tell you it's between 2 and 3, right? Because 3 squared would be 9 and 3 cubed would be 27, but I don't know what actual power it is. So this is kind of the thing where now we're actually going to use logs to solve a problem we don't already know the answer to. Whereas all the ones before were kind of just understanding how logs worked. Now we're actually solving an equation. Mango, it's up to you. There are kind of different options. You don't have to have a graphical calculator. It does have certain advantages, but they are very expensive. This calculator, the one I'm showing on screen, Casio don't technically make this one anymore, but you can still find them places. If you can get hold of one of these, it's great, right? I've taught maths and further maths kids using this calculator that have got A's and A stars. It's perfectly good, does everything you need it to. But as I said, you can get graphical calculators. They just cost a bit of money, and then you have to figure out how to use them, which sometimes takes a bit of time. Right. So we're going to try and solve this by writing the log statement. That's the thing, right? So we're taking 3 to the power of x equals 17, and we want to write the log statement that then has the bits rearranged in the right place that we could then type into our calculator. Okay, so this is an example showing what I'm talking about. So CG50, the graphical one, it is in there. It's buried in like a menu somewhere under like math. It's been a while since I've looked at my CG50, so I can't remember off the top of my head, but it is in there somewhere. So for now, just write down what you would type in, and later on, you can then find the function and do it properly. Okay, so we want our log statement written down. That's the key bit, because then if you've got that, it's just calculator's going to do the rest. So here's my base. So log base 3. Okay, this is my answer. So I'm going to stick that there. And then that equals the power, which is x. So I've got log base 3 of 17 equals x. And that just goes into our calculator. So you can see everyone's done it, right? So who's got the calculator and has found the right button. If I was doing it on my one, I'd do log bit there where I can put the base in. I can type in 3. I can type in 17, press enter. 2.58 because we're rounding to 3 significant figures. So I say x equals 2.58. Job done. I've solved one question. We're off. Look at that. Fantastic. Okay. B, same thing. So this is what I mean, Yashi. So there will be a button somewhere on your calculator, buried in a menu on some of the new ones. They don't put it as a button, and that's why I like this calculator. As I said, I don't know why Casio stopped making it and changed some things. This had all the buttons you would want to need, kind of really easy to find. The newer version that Casio have done, there is the button on there or function on there, but it's like in a menu somewhere. So this is where, the same one. It's this button here then. So if you kind of check, there's like this log next to kind of top right corner-ish. There's like a log with 2 little boxes after it. And then you can type the base in after that, right? So it kind of highlights the thing. So if I do an example here, look, so I can do that. Okay, and then I can type in my base and then type in my number. Okay, so if I write my log statement from there, okay, so again, my base is 7, so log base 7, okay. What comes next? The 2x or the 100, right? If we've recognized the base is 7 and we've written log base 7, we've only got 2 things we can put there. It's either 2x or 100. So what do I put there? Don't worry about that, Moonlight. We're going to fix that in a minute, right? That's the easy bit. What's the next bit? You've got it, right? So Moonlight, you've written it out, yeah? So after my log base 7, then I goes my 100, and that equals 2x. So log base 7 of 100 is just a number. It's just a number. What power do I put on 7 to get 100? My calculator will tell me. So the fact that it's 2x doesn't matter because I can find that number, right? So I can finish off on my calculator and say 7 there, and then jump across and put the 100 in. Dum-dum. So I get that. That's not my answer because my answer, at the moment, that's 2x. So that's 2.366, blah, 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 blah. So in this case, then we just do normal algebra, which most of you already done, because I can see loads of you are way ahead of me. Christy was miles ahead of me. Shay, you got the kind of, oh, that was the answer for the previous one, wasn't it? Shane, yeah, you got the idea, way ahead of me. So all I need to do is then divide by 2. So I just take my answer, divide it by 2, and now I've got my 1.18 three significant figures all sorted. 1.18, boom. Easy stuff. Light work, as we is the phrase we're using these days. Okay. Now C has a potential to catch us out. What's the problem with C? If you look at C as it's written now, right? Because I can see not many have felt confident enough to go on and do C, or at least not type it in the chat anyway. What's the problem in C that means we can't go straight into what we've done so far? We're not a million miles away, but I can't go straight into what we've done so far. Now, there aren't two bases, okay? There is only one. Remember, the base is the thing with the power, right? There aren't two things with powers, there's only one. So there aren't two bases, but what's the problem with what's there at the moment? Don't have to have a base 2 in both sides. That's a bit like the kind of rewriting things. Log small 2, I like that. Big 22 over 5 minus 3, then divide by 2. Okay, so buried in what Shane said and what he's kind of, and what Sanjay's just kind of written out now, the 5 is a problem, but look, that's 5 times this 2 to the power, right? So I don't need to expand the bracket. There's not really anything to expand. I don't want that 5 there. If that 5 wasn't there, it would be 2 to a power, 2 with a power equals a number. And that's what these other ones have been, right? These have been something with a power equals a number. That's what they've been. So if we can get to something with a power equals a number, then we're good. Okay? So all we need to do is just divide by 5. Okay? Because if I divide by 5, now it says 2 to a power, which is what we want. We want that, don't we? We want 2 to a power, because then we can do a log, equals 22 over 5. Boom. Now we're doing the same question we did in the 2 before, right? Now we're doing something with a power equals a number. So that's nice and simple. So now I can take that and write the log statement. So I couldn't write that log statement until I just had the base on its own, if you like, with the power, and every other number was then kind of on the other side, right? I had to do that first. Okay, so now I've done that. Now I can write my log statement from here. So 2 is my base. So I've got log base 2 of 22 over 5, or obviously if you've divided it 4.4 if you like, that's fine, equals 2x plus 3. So I'm just going to pause there and just check and make sure everyone's happy, right? Because this is now a little bit more of kind of the sort of thing you might see, a bit more challenging. So 2 to a power equals a number. We got there. Now we can write our log statement. We've then got to go on and solve the equation, okay? But that's okay, right? So then, well, remember, log base 2 of 22 over 5 or 4.4 is just a number. I can get that number from my calculator, can't I? Right? I can go over here and do log base 2, 22 over 5 or 4.4, depending on which version you want to put in. I'll do the fraction. I get that, right? It's just a number. So if I then wrote that number and said, oh, right, now it says, I'll switch back to reds for consistency, 2.1375 equals 2x plus 3. You all know how to solve that. I know 100%, every single one of you then knows how to carry on from there and solve it. So it's just that step of getting the log statement when we've got that kind of extra complication in the first bit. Okay? So after we've done that, we can now go on, as I know a few of you have done, and say, right, I take that answer, take away 3 to get that, and then divide by 2, kind of like normal, to get that, right? And then minus 0.431, that's okay, right? Because remember, the x, because I know you might look at it, nice one, Share. So you might look at it and say, oh, but so, you know, I said you can't have negatives, right? Well, remember, that negative is x, which is in the power. You can have negative powers. That's fine, right? There's no problem with negative powers. Yeah, Christy, you're absolutely right. There's no problem with having a negative power, it's taking the log of a negative. That's different. That's the problem, right? You ever try and take log of a negative, that's when your calculator says, no, sorry, you can't do that. But if you want to have a power that is negative or has a negative in it, that's not a problem. So minus 0.431, awesome stuff. Strong answer. All right. I reckon now that we've talked about that problem in terms of that 5 and what it did, now you might feel a bit more confident about D, right? So some of you now might be kind of cracking on and going through and solving what D is, because now you understand well the stage you need to get to be able to do that. Okay. So if you have and you're going working through that, go for it. All right. I'll kind of start working through that in a second, just so that those of you who aren't sure, you can try and follow along and pick up a bit extra. But it's the same thing, right? So I'm going to put in a time sign just to help, because I know sometimes you might think that's a bit weird when you have a 3rd and a 4 next to each other without anything in between. Okay, so that. All right. So that's my starting point. Can't take logs. Absolutely not. No way. Right. I see it happen all the time. People just start sticking logs in stuff. Right. As I say, I mark A-level papers. Happens every year. Someone just starts writing log this, log this, log this, blah, blah, blah. Can't do it yet. Right. No good. So don't start that. We need to get to base and a power. Power. Right. Base and a power. So in this case, again, I'm not saying it's difficult to get there, but we would need to bump this 3 across, right? Because that's a problem. That's kind of not just base and a power. And also the 3rd as well, right? Both of those things need to move so that then we can get on to our next bit, all right? So if I have 4 to the power of 5x minus 2 equals, and then I've added 3 and times by 3 or divided by a 3rd, whichever version you'd rather have, to get 9. There we go. All right, Moonlight's had a go at writing out our log statement. Awesome stuff. Well done. This is what I mean, right? Once you've got it, it's all the same stuff. We can dress it up and put 5x minus 2 as a power, and we can have a minus 3 and a 3rd, but it's actually all the same as the stuff we were doing on that first page. I know it feels like a bit more because we're just kind of adding little bits on, but I promise you it's still the same thing. Okay? Moonlight, you are an awesome example of if you just kind of go with it, right? You just kind of go with it and say, do you know what? I'm not 100%, but I'm going to stick with it. It will start to click, right? You just go with it. Sometimes if you get too hung up on, I haven't understood it straight away, then you kind of get in your own way, right? And you stop yourself from understanding because you've kind of already decided you don't get it, right? Awesome stuff. So as we've seen, as a few people have kind of had a go at typing out, I've got log base 4 of 9, right? So there's my base of 4. 9 was my answer, and then 5x minus 2 is my power. So I rewrite there. So 5x minus 2 log base 4 of 9. So if I left it in an exact form, right, which you don't have to, I'll stick it in a calculator in a minute, I'd have plus 2 and divided by 5. So that's one, I could type all that into my calculator in one go if I wanted to, or I can do it in stages like we did before. So I can do log base 4 of 9, get that answer if I like. So I do that, and then I need to plus 2 and then divide by 5. Okay, and then I've got my answer, which again, I know some of you were way ahead, right? So you kind of check back, path was in there, fantastic. Yashi was in there, awesome. And Cher's got it, there we go. So we get x equals 0.717 if we're rounding. Okay, awesome stuff. Okay, as I said, I'm pretty confident. There's at least a few people looking at it going, I'm not sure about this. That's algebra, right? So if I've got something there, remember you could have divided by the whole thing by a 3rd or times by 3 if you wanted to first, but then that would still have made that a 9. Okay, easiest thing to do is always to move any pluses or minuses first and do the timesing after, right? So that's like your algebra stuff from GCSE. If you remember solving things like 2x minus 3 equals 5, right? If you remember, the standard thing you do is add the 3 first and then divide by the 2. It's like the kind of easiest way to go about trying to solve your equation. Okay. All right. So we're going to try and go. We're pushing it a little bit, right? We want to try and push it a bit. So I thought about this in terms of whether we would do this or not, or whether we'd maybe leave this, because I want to leave some time at the end to kind of answer any questions you've got. So while this is an hour lesson, obviously we had a bit of an intro at the start, and I want to kind of give a chance to talk to you at the end and kind of answer any questions and stuff. So we might not necessarily fit every single thing that we would kind of typically do in an hour into this, because we're kind of chopping a few bits just to kind of give that time to talk to you and stuff. So what I'm going to do is, I'm not, good question, because I want you to have a go at the bits on the next page. I'm just kind of curious about, I'm just trying to think how long we've got and how long I need to be able to talk to you for at the end. What we'll do, I'm going to prove one of them. So I know it says here, we're going to prove, it says prove the multiplication and power laws. We're just going to prove this one. You do not need to know this. You don't need to know the proof, but it's nice for those of you that are kind of maybe, you know, keen mathematicians, right? Don't worry, it's cool. You're in a good environment where you can be a keen mathematician. Might be interested to know where it's come from rather than me just telling you it, right? So these are true. This ultimately, this is what you need to know. You just need to know those, okay? But I'm going to show you where one of them came from so that you can kind of say, oh yeah, that's quite interesting actually. I quite like that. All right. So I'm going to start with this bit here, this left-hand side of this multiplication law, and say, pick a random letter, doesn't matter what it is, p equal log base a of x plus log base a of y, right? So I'm just picking a random letter to let it equal. That's just a placeholder, right? As I said, don't worry about this. If you don't follow this, don't worry about it. You just need to kind of know those three laws. But as I said, I'm just going to show you for those of you that are interested. So if I do all of that, I raise both sides to make those a power. So a to the power of those. So I do a to the power of the left side. So a to the power of p equals a to the power of all of the right side. So that's all a power. Okay. Now, rules of indices mean that if I have a plus sign in my power here, what does it mean if I'm adding powers? That I'm sure you remember. What does it mean if I'm adding powers? It's one of your rules of indices. Probably the first one that you learn. Okay? Come on, guys. I need you to remind me. I know we're busy trying to saying what A levels we're doing, which is good, right? Because it's nice to know. But what does it mean if I'm adding powers? Well, no, I am adding it. I'm adding the powers. I could add it, but I can't add those two things together. What does it mean I did to get my powers added? Do you remember where adding powers came from? So I think Sanjit's got it. You've got the idea. I need the same base. Remember, this is all one power. So what it means is that I could rewrite this as a to the power of log base x times a to the power of log base a of y, right? Because that was all the power, that thing that was written here, right? Funkar's got it, fantastic. So I can split it by saying I could times that together, and that means I would be adding the power. So I'm using it the other way around. Now, if I look at that, this is a to the power of log base a of x. That's the inverse function. So those bits cancel out, which gets me x times y. Okay? So at the moment I have a to the power of p equals xy. And if I take log base a of a to the power of p equals log base a of xy, then on this side, log base a of a cancels out, and I'm left with p equals log base a of xy, which is the same p that I wrote here. Okay? So I'm pretty confident that I've gone through that a bit quick and that no one's really kind of necessarily taken that on board. Don't worry about that one. But look at these laws up here because you're about to need them, right? For the last little bit we're going to do, it's the last bit for today. I want you to have a go because this is the very realistic thing that you might have to do in A-level type of questions, all right? So have another look at those laws. Make a note of them if you want to. So if I have log x plus log y equals log of x times y, provided the bases are right. Yeah, just memorize them. That's what we're going to do. You would not need to prove them. That's just me giving you a demo of kind of why they work, right? Remember the division law. If I have log x minus log y, that's the same as log of x divided by y, provided the bases are all the same. And if I have log base a of x to the power of k, that's the same as k times log base a of x, because we're about to use all of these to answer these questions. And this is the end, right? This is the last bit we're doing. So, simple test. I'm not using a calculator for this. I'm not working anything out. We are writing as a single log. Okay? So, if I have log of 2 plus log of 3, and I check my little rules that we just said we need to remember, don't need to prove them. I don't need to sit here and prove this. I just need to quote what it is. That is log of what? What can I put in there? There we go. Look, right. So if you've got it and you use those rules, so as I said, look, I can flick back, remind you, we're talking about this first one here. I have log of something plus log of something. That's the same as log of the two things times together. So I could write 2 times 3, but obviously you all know that 2 times 3 is 6. So it's absolutely fine to just write log 6. Okay, no one's expecting you to write down log of 2 times 3. That's the first one done, right? Log 6, done. Okay, remember I don't need to, because it's assumed notation, I don't need to write the 10. Okay, because if I don't write a base, it's 10. That's just fact, right? It's mathematical notation. So for the next one is a minus. So if I go back and just check, remind myself, if it's a minus, then I divide them. So I go back here and say, right, I've got log of 10 minus log of 2. Then I've got log of 10 divided by 2, which is just log 5. Okay? So this is the stuff that you actually need to kind of be able to use. So you will get questions on A-level papers like the ones we've done so far, and you will also get questions of this sort as well. Okay? So this one, you can't put them together yet. It's a bit like the thing we had before with the equation we were solving and the 5 in the front. We couldn't do that yet because of this 2 here and 4 here. So if I go back, this time I can use another rule first. So if I go back and check here, my power law says that if there's a number in front of my log, I can take that number and put it as a power instead. That's really helpful. That's a very, very helpful thing to be able to do. Okay? So I can move a number in front of a log and make it a power instead. So if I look here, I can take this 2 and move it to be a power. And I can take this 4 and move, sound like a cow now, move it to be a power. So if I do that in 2 steps, right, to show you what I've done, I've got log base, log base 10, but log of 3 squared plus log of 2 to the power of 4. Okay? I can work those out if I want to. So that's log 9 and log 16. And that means I can now use the other rule that we already used in part A, question A, of now saying that's log of 9 times 16. Okay, which is log 144, which a few of us have stuck in the chat. All right, this is more realistic of the sort of thing that you might need to be able to do. Okay, as I said, you will also get equations like the other ones, they do happen, but this is the most common question, asks you to use rules of logs in some way. All right, so if I do the last couple here, so we've got this half, so that's a number in front, so I can make that a power. And I've got this quarter, that's a number in front. This sort of question would probably be only like kind of 2 marks. Yeah, I know a couple of people are kind of curious about that. Remember, don't worry too much about marks at this stage. You know, your exams are a long way away. So, you know, just let's learn how to do our log stuff first, and we can worry about our stuff later. So if I rewrote that, I've got log of 3 to the power of a half minus log of 4 to the power of a quarter. Okay? And then I can move that across and say, or well, not move that across, sorry. Rewrite it using my rule. Right now I've got the minus, so I can do log of 3 to the power of a half over 4 to the power of a quarter. Okay? So just be careful, Shane, because I think you've multiplied them, so you'll be careful. So it was a minus sign, so it means I have to divide. So if I check that, I can write that as, there's not a nice answer, but if I can write root 3 and then 4 to the power of a quarter, don't worry too much about it, but it's effectively square rooting twice, so I can end up with root 2. Okay, but as I said, that's not necessarily simpler, but there you go. Okay, so last one I'm going to ask you to do. So use the little up thing. So this is how you do powers, right? You might know that. So the little thing there, like 2 to the power of 3. Okay, we might be used to kind of that sort of stuff. So have a go at what you'd get as a single log once you've done all of the stuff you need to do in E. So all of these, you're going to get log of something. So have a go. So how did I rewrite them? So which one, Funkai? If you can be a bit more precise, which one are we talking about? Like the first one? Second one? Third one? Because if we start, the first one was meant to be the simplest one. So if we're starting there, then that's fine. D. So D, as I said, don't worry too much about the numerical stuff. So what I've just moved it to powers, right? So 3 to the half and 4 to the quarter. Then because it's a minus, I can divide them, right? And then what I've done here is then kind of indices stuff, right? So power of a half we know is root 3. Power of a quarter is the fourth root, but it's the same as square rooting twice. So if I square root 4, that's 2. And then I'd square root again, and that would be root 2. So I've done that. You wouldn't necessarily have to do that, but I've done it there as an example. Okay. So got quite a few then who are starting to kind of type their answers in while I was explaining that. Awesome stuff. So it's going to be log, right? So we've got log of. So if we check through, these ones actually you might find are easier than some of the kind of A to D ones, right? Because you're just using letters and stuff. So I've got first one has 2 log A. So I could write that as A squared, log of A squared, but log of A squared. Then next one is 5 log B. So I can do B to the power of 5. Okay, because it's got 5 in front. And then the one after has got 3. So I could move that and make it C cubed, right? So I can do all that. And then I can do the bit by combining them. So if I do it individually first, so I can do log of A squared plus log of B to the power of 5 minus log of C cubed, right? That's my kind of first bit I can do with all 3. Then I have a plus between these two, so I times those together, and a minus between these ones, so I put a divide, which is what lots of you wrote down. So A squared B to the power of 5 over C cubed. Okay, awesome. As I said, we would have a bit more time normally, but because of the intro and then I need to kind of have a chat with you now, we're obviously slightly shorter, so we don't have as much chance to kind of go through. I'm going to leave the last one for you to have a go at yourselves, right? So I'm not going to tell you the answer, right? You can try that yourselves independently. And then when we come to main course, we might have a chance to kind of check those of you that have had a go and got the right answer. I think you'll be fine. You can get that. It's no problem. It works out quite nicely. So this is your chance then to ask questions about kind of how it works. I've got some things I can explain that hopefully will answer some of them, but if you do have questions, I can hang around for a few minutes after to help kind of answer any of those if you've got questions and stuff. So hopefully you've enjoyed it. I've had a blast, right? Great job. You've been sticking answers in, asking